Assalamualaikum and good morning. So today we proceed to second chapter. Second chapter is about atomic structure. So in this chapter we have three subtopics. Okay, first subtopic we are going to learn about Bohr's atomic model. Okay, before this you have learned about Rutherford atomic model in school. So Bohr's atomic model is a model that explaining or the additional postulate that explaining what Rutherford cannot be explained. Okay, and for second subtopic is about quantum mechanics, how we calculate the movement of electron in this atomic model. And also, and last subtopic, electronic configuration. Okay, how do we write the coordinate or position of electron in a molecule? So these are the learning outcome. We start with describe Bohr's atomic model. Okay, we will explain how energy level form or exist in atom and simple calculation about energy for electron when it move and also at certain position. Okay, the fourth learning outcome. Okay, describe formation of line spectrum, how this line spectrum form when electron move. And for the last one, we have three different formation of line spectrum. We have five different formation of line spectrum. Okay, when electron move, it will form a light. So this light we can see, okay, with our eyes, we call as visible light. So this is the range for visible light, okay, in nanometer, 400 nanometer to 750 nanometer. Okay, other than that, we cannot see with our bare eyes. So this is the electromagnetic radiation, or actually we have covered this in your school. Okay, wavelength, lambda. So frequency equal to C over lambda. This one is frequency. C is speed of light over lambda. Okay, and we can calculate energy, okay, E, by multiply frequency and also constant. H is known as Planck constant. Okay, because of this visible region, we can see light in different color. Okay, because light in certain color has its certain wavelength. Okay, actually Rutherford atomic model was quite commendable when it came to explain the structure of atom. Okay, however, it was not very appropriate theoretically. Okay, why we are saying so? Because we know that any charged object that revolve in a circular motion gain acceleration gradually. So, when the electron is moving fast in circular path, it will also gain acceleration. So, when gaining acceleration, it's bound to liberate energy in some form. Okay, how if it continues keep radiating energy? What happened to the electron? Yes, it will fall back into the nucleus. Okay, then it will cause the high instability of the atom. But it do not happen in all atoms. Because in nature all atoms are stable. So to explain this hypothesis, we need a slight modification that made by Bohr. So we go to the first postulate of Bohr. Bohr made a few additional explanations to describe this atomic structure. Okay, the first postulate of Bohr that electrons are moved in circular orbit around the nucleus. So this electron does not radiate or absorb any energy when it moves around the nucleus. Okay, it will only move in circular orbit, in certain orbit. So this is the first orbit, second orbit, and the third orbit. So second postulate of Bohr, the energy of electron is quantized. Okay, what does mean by quantized? Quantized means this electron, when it moves in the first orbit n equal to 1, it will have specific energy. The energy is different with electron when it moves in second orbit. So that energy we call as quantized energy. So to calculate this energy, we'll use this formula. E refers to energy, N refers to orbit. Okay, so orbit we start with the lowest orbit n equals to 1. So En equal to negative RH times 1 over n squared. So R refer to Rydberg constant. So 2.18 exponent negative 18. So because of energy associated with force of attraction, the energy of electron at certain orbit will be negative. So that's why kita ada this negative sign. For example, to calculate energy of electron when it moves at first orbit n equals to 1. So we have the formula En equal to negative RH 1 over n square. So R is Rydberg constant 2.18 exponent negative 18 times 1 over n square, 1 over 1 square. So we have the energy negative 2.18 exponent negative 18 and so on until here n equals to 3. So the energy of electron at different energy will different. So we have n equals to 1, n equals to 2, n equals to 3, and so on. So this energy we call as quantized energy. Okay, so this is the energy level. Okay, we have two different forms in drawing of energy. So this one we draw in form of orbit, meaning this one is nucleus. Okay, and we start with the lowest orbit, n equals to 1, n equals to 2, n equals to 3, and so on. So when we convert this form of drawing dalam bentuk orbit ni kepada energy level diagram. So this one we call as diagram for energy. So we have here is energy. Okay, or in specifically we call as potential energy. So we have and the lowest n is n equals to 1. So the difference between n equals to 1, orbit 1 and second orbit are large. So the space is bigger compared to the other. So bila dia semakin tinggi energy level tu, dia punya space semakin dekat. Okay, yang ini menunjukkan space ni menunjukkan different in energy. Maksudnya perbezaan antara energi 1 dengan energi 2 sebesar ni. So perbezaan antara energi 2 dengan energi 3, this large. Okay, so dan seterusnya. So Bohr's atomic model 3. So pada lowest energy level n equals to 1, okay, dia akan ada lowest energy, we call that as ground state. Okay, energy yang paling rendah pada n equals to 1. Okay, what happen when energy is supplied to the electron? So bila dia supply energy, electron will absorb that energy and it will excite. So what happen in excitation? What happen when electron is excited? Okay, macam kamu dapat energy selepas makan, apa yang kamu buat? So boleh bergerak. Okay, so same goes to this electron. It will excite to higher energy level. So we cannot say that excite move to the lower energy level. So excite mesti bergerak pergi kepada yang lebih tinggi. For example, here when n equals to 1, it will excite to higher energy level. So higher energy level than 1. So we can say that n equals to 2, n equals to 3, 4 and so on. So mesti from lower energy level to higher energy level. So when the electron is excited, so we can calculate the difference of energy. Okay, so energy final, EF refer to energy final minus E1, EI. EI is energy initial. So initially, it start from N1, first orbit. So it excite to second orbit. So if F, E final is second energy level. So we can calculate the difference between energy level sebanyak ni, 1.6 exponent negative 18 joule. Okay, sama juga kalau dia excite daripada 1 to 3, 1 to 4 and so on. So we can calculate the difference of energy. So what happen at higher energy level? Okay, macam kamu tak akan selama-lamanya kita akan pada higher energy level. So kita akan gunakan tenaga dan tenaga tu akan habis. Same goes to this electron. At higher energy level, the electron is unstable. So what happen? It will fall back. So bila dia fall back, dia akan release energy. So this energy we can see in form of light. So meaning cahaya yang kita boleh nampak tu, visible light tu hanya apabila elektron tu drop to lower energy level. So dia mesti bermula dengan excitation daripada bawah pergi ke atas higher energy level, dan dia akan drop back. So masa dia drop back tu dia akan menghasilkan light. Okay, so drop back to lower energy level. Okay, for example, kalau elektron tu excite from N1 to N5. Okay, for example, dia pergi kepada 5th energy level. Okay, dia tak semestinya dia akan drop back to N equals to 1, initial level yang dia bermula tu. So dia mungkin boleh drop to N equals to 2. Okay, tapi mesti lower than 5. Mungkin N equals to 3. Okay, yang penting dia akan drop back to lower energy level. So for Bohr atomic postulate, remember we have 4 postulate for Bohr. Okay, the first one, the electron move in circular orbit. Okay, yang ini yang tidak dapat di-explain oleh Rutherford. Okay, so untuk hydrogen atom, okay, kita belajar untuk hydrogen atom saja because elektron untuk hydrogen ada satu. So kita akan refer to the movement of this one electron around the orbit. Okay, the second one, when electron travel ataupun move around the orbit, okay, dia akan ada specific energy. So kalau kita ada different energy, N1, N2, N3, kita akan ada different energy. So this energy yang berbeza ni, yang tetap ni, kita panggil sebagai quantized energy. Okay, the third postulate of Bohr, okay, when energy is supplied, Okay, bila kita bagi energy kepada elektron, elektron ni akan absorb that energy and excite to higher energy level. So what happened at higher energy level? The electron is unstable and it will fall back to lower energy level and release energy in form of light that we can see. So ada 4 Bohr atomic postulate. So we can calculate the difference of energy using certain formula. Okay, last time we calculate using energy final minus energy initial. Okay, so this one we can also calculate using H times V. So V refer to frequency. Okay, so this one you can cover in this calculation will be covered in your tutorial class. Okay, then we continue with spectrum. So we have 2 types of spectrum, continuous spectrum and line spectrum. Okay, what are the difference? So this continuous spectrum, okay, continuous meaning dia bersambung-sambung. So each color ni dia akan overlap. So meaning dia tak ada distinct boundary. Tak ada yang tetap di mana dia berhenti. Contohnya sini warna biru dengan warna hijau, dia tak akan ada satu space yang menunjukkan yang ini memang hijau je. Dia akan ada overlap between these two color. So this continuous spectrum, okay, we can say that consists of all wavelength of visible light. Dia hanya ada range saja. Dia tak akan ada berapa panjang gelombang dia yang tetap. So this continuous spectrum is from white light. For line spectrum, okay, line meaning ada satu distinct line. Ada satu line yang tetap. So this line consists of certain wavelength. Okay, we can say that this line at berapa wavelength dia. Ada certain wavelength. Sama juga untuk line yang warna hijau, biru dan seterusnya. So each line correspond to particular wavelength. Panjang gelombang yang tertentu. So untuk line spectrum, dia terhasil daripada discharge tube. So ini contoh perbezaan antara continuous spectrum yang atas sekali tu. So continuous spectrum tampak kita tak ada gap between each color compared to line spectrum. Okay, so these are the table to show that the difference between continuous spectrum and line spectrum. Okay, actually the formation of line spectrum is accordingly dengan Bohr atomic third and fourth Bohr atomic postulate. So electron at ground state n equals to 1 absorb energy and excite to higher energy level. At higher energy level, the electron is unstable and it will fall back. So bila dia fall back, dia akan release energy in form of photon. So that one we can see in form of light. So yang itulah yang kita boleh calculate wavelength for each line. Okay, so tadi kita mention bila electron tu absorb energy, dia akan excite to higher energy level. Okay, so for example, electron start from n equals to 1, excite to higher energy level n equals to 2. So then, dia tak ada choice untuk drop. So dia hanya ada satu je choice, dia drop kepada n equals to 1. So, kalau second electron, contoh, kemungkinan elektron yang lain daripada n equals to 1, dia excite kepada higher energy level, for example, n equals to 3. So, bila dia excite kepada n equals to 3, dia ada dua choice untuk drop back. So, kemungkinan yang pertama, dia drop kepada n equals to 2. Kemungkinan yang kedua, dia drop back kepada n equals to 1. So, in this case, we say that the possibility ada dua. So, bila all electron drop back to n equals to 1, Okay, we say that dia ialah in Lyman series. So we have 5 series of hydrogen emission spectrum in Bohr. So when all the excited electron daripada higher energy level tu, tak kisahlah daripada n yang keberapa, drop back to lowest energy level, n equals to 1, we say that it is in Lyman series. Drop to first energy level. When all the excited electron drop to second energy level, we say that it is in Balmer series. Okay, untuk partition n equals to 3, bracket series n equals to 4, fun series n equal to 5. So just remember where the electron drop. So to remember this, okay, Lyman, Balmer, partition, bracket and fun series. Okay, so I remember as mnemonic Lyman, balik, pasal, okay, bracket BR, break, putus. Okay, then we can use this calculation, this formula, we can use this one to calculate for wavelength. Okay. To calculate for wavelength, so actually for different series, kita akan ada different initial orbit. Okay. So when the electron drop to n equals to 1, okay, kita akan ada the first orbit, initial orbit ialah 2. So 2 to 1. So that's why we have initial orbitnya start from 2. So 2 drop to 1, then 3 drop to 1. So meaning initial orbit ni mesti lebih besar 1 compare dengan di mana dia ada drop. Okay, for example for Balmer, okay, all the electron drop to n equals to 2. So dia punya initial orbit mesti start daripada 3. So 3 to 1 will form the first line. Okay, same goes untuk partition. 4 to 3 we form the first line in partition series. So ini dalam diagram ni tadi. So untuk recognize ataupun untuk kita tahu macam mana kita nak calculate, so kita just tambah untuk this one. For example, first line in Balmer. Okay, so kita tahu Balmer, all electron drop to n equals to 2. So first meaning 1. So 1 plus 2, 1 plus 2 become 3. So meaning untuk first electron in Balmer, the electron drop from initial 1, 3, this one, 3, 2, and finalnya ialah 2. Kamu just remember yang inilah, dia drop pergi mana, kemudian kalau untuk tahu first line, maksudnya line yang pertama terhasil dalam Balmer tu, bila elektron bergerak daripada 3 kepada 2, macam ni. So dalam Balmer, okay, first line yang Balmer this one. So elektron daripada 3 pergi kepada 2. So N3 to N2 untuk first line. Okay, kalau dia ialah for example ya, second line. Okay, second line yang produce in bracket series. Pergerakan elektron tu daripada berapa pergi ke berapa. So N initialnya berapa, N finalnya berapa. So kita tahu in bracket series, Leman balik pasal break. So break. So ini 1, 2, 3, 4. So break ni 4. So kita tahu 4. Dia akan all electron drop to 4th energy level. So untuk initial meaning dia start daripada berapa? So for second line kamu just tambah dengan final orbit. So 4 plus 2 akan jadi 6. Meaning elektron tu akan bergerak daripada 6 energy level to 4th energy level untuk menghasilkan second line dalam bracket. So kita tengok yang ini second line dalam bracket. So sini N6, 2 and 4. So nanti kamu akan guna calculation ni dalam tutorial. Okay, so just remember untuk N initial mesti lebih besar daripada N final. Sebab N initial ni refer kepada daripada excited state. So N final tempat dia drop ataupun lowest energy level. Okay, so ini contoh untuk identify first line, second line, okay, in certain series. So for example yang ni untuk Balmer series. So Balmer kita tahu semua elektron drop to n equals to 2. So for first line mesti higher daripada 2. Higher 1 orbit daripada 2 ialah 3. So 3 to 2. So yang ni yang saya mention tadi. So untuk calculate, okay, first line tambahkan dengan tempat dia drop. So 1 plus 2 akan jadi 3. So this one n equals to 3. So kalau untuk second line, so second meaning 2. So second is 2. So 2 plus 2 akan jadi 4. N equals to 4. So kalau third line, so third line refer to 3. So 3 plus 2. 3 plus 2 ialah 5. So dia akan start dengan 5. So untuk lukis line spectrum in energy level diagram, okay, make sure spacing ni betul, meaning difference spacing between N2 dengan N1 ni larger compare dengan N2 and N3. Okay, semakin tinggi energy level, spacingnya semakin kecil. Dan lukisan tu sama ada boleh lukis daripada first line kepada third line ataupun daripada third line kepada first line. Mana-mana pun boleh. Yang penting arrow tu mesti ke arah bawah menunjukkan the electron drop. Okay, contoh soalan ni. How do the second line of Balmer series produce? Okay, so kita tahu second line meaning 2. So Balmer, yang tadi, Leman balik pasal. So Balmer meaning all electron drop to 2. So 2 plus 2 jadi 4. So dia akan drop daripada 4 to 2. Second line. So this one. Daripada 4 kepada 2. Okay, selain daripada kita calculate movement of electron from which orbit to certain orbit, so kita boleh juga identify which line yang akan produce highest energy level based on this formula. V equal to C over lambda dan juga delta E equal to H over V. So which line produce the highest energy? So highest energy meaning E yang besar. Highest energy, so refer to perbezaan. Okay, so actually yang ini menunjukkan energy difference. Besarnya energy tu, besarnya line tu menunjukkan besarnya energy. So which line has the longest wavelength? So longest wavelength kita akan calculate daripada formula. So kita tahu E equal to H C over lambda. So kalau dia mempunyai, okay, yang ini menunjukkan energi yang kecil. energi sini rendah, so wavelengthnya akan jadi tinggi. So that's why A has the longest wavelength. So which line has the lowest frequency? So apalah hubungan frekuensi delta E equal to HC over frekuensi V, HV. Kita just guna yang ni lah. So V equal to C over lambda. So kalau longest wavelength, frekuensinya akan jadi, okay, ini inversely proportional, lowest frequency. Okay, so that's all for 2.1. Thank you, class.